Okay, so we can take our vectors and we can put them in the coordinate plane, right? Remember how I said a vector has its initial and its terminal point, right? So if we put that in a coordinate plane, then the initial point has its own coordinate, it's x1, y1, and the terminal point has its coordinate point, x2, y2, all right? Now, so how would we write the component form of a vector then? To do that, what I want to do is I want to give it, so basically I want to describe that vector, all right? And I want to give information on how I can create that vector, where I need to start and where I need to end, basically, right? Like how I can create this vector. Okay, so to go from A to B, right? I could go along that diagonal, or I could go along horizontal and vertical components, right? So I have to go along this red line a little bit, right? I have to go along the horizontal line for some amount of time, and then I need to go along the vertical line for some amount of time. So suppose my initial point here is at 3, 5, and my terminal point is at, I don't know, 7, 9. Okay, so how much along the horizontal do I need to go? From 3 to 7, that's a total of 4 units, right? 7 minus 3, that equals 4. And how much do I have to go up? 9 minus 5, that also equals 4, right? So in component form, I can describe this vector as 4, 4, meaning if you start at the initial point, you go 4 horizontally, 4 vertically, and you get to your terminal point. Okay? Okay, so rather than parentheses though, okay, now we know the 4 and the 4. Rather than parentheses, to describe the coordinates, to describe the components, I use brackets. So when I have something like this, what this means is, okay, I've got a vector. The horizontal component is 4, the vertical component is 4. So the formula for it is this, all right? So it's in the brackets. You cannot use parentheses. It's in the brackets. And the way in which we find it is you subtract the x's, comma, you subtract the y's. So take a look at AB here. And to find the component form of vector AB, all right, what I have to do is, in my brackets, subtract the x's, 1 minus 1, comma, subtract the y's, 3 minus negative 3. You have to make sure to keep the order the same though. It's not like slope where it's okay to, to say AB or BA. You can't switch the order. You have to keep the initial point first and the terminal point. It's x2 minus x1. It's b minus a. Okay? So AB in component form is 0, 6. Okay? So let's plot these points. Okay, so A is at 1, negative 3. Here is A. B is at 1, positive 3. Here is B. Okay? The vector from A to B is this with the arrow pointing up. Okay? So how do you go from A to B? Well, look at this vector, look at this component. You go 0 horizontally and then you go 6 upwards. That's how you go from A to B. Right? Now, had you done this the other way, had you done negative 3 minus 3, then you would have gone down and you would have gone, your vector would have been pointing in the wrong direction, right? Which makes all the difference in the world. Okay, So what about the magnitude of this vector? What about, now we know like how to go from one to the other, but how long is this vector? Well, since the magnitude is length, we have to use the distance formula. All right, and do you guys remember the distance formula? There we go. Okay, if you don't remember, now is the time to learn. So that's the distance formula. Now, look at what we just did. Remember in component form, what did we say x2 minus x1 is? That's the first component of the vector. y2 minus y1 is the second component of the vector. So going back up here, another way to write all this is a comma b, where a is the horizontal component. Here, a is the horizontal component, b is the vertical component. So, if you want to find the distance, you could either, do it from scratch, x2 minus x1, or if you've got the components, you just do the square root of a squared plus b squared. Okay? Yeah, and it's also not not bold, or, it's a scalar. Okay? So, here we go. So we could use either of those. All right, so let's find the magnitude of AB. The magnitude of AB, it's got to have the bars around it, okay, is what we need to find. Now, do we have the vector? So what is the component form of AB? This happens to be like, it's the same one that we used before. What was the component form? It's 0, 6, right? So the magnitude of it is the square root of the first number squared plus the second number squared. So this is just 6. So magnitude of AB is 6. And yeah, we could already tell, right? Because it's just a vertical line. But, yeah. Huh?
How do you know the difference?
That's awesome.
It's asking to find the magnitude. Oh, so this is like if we don't have a diagram.
Yeah. Yes. Okay, if you have the components. All right? Okay, so. Yes, I can. I'm so sorry. Okay. Okay. You can sit in this chair. Okay. Okay. So addition, subtraction, and so on and so forth. Addition is the same exact way as we did for the matrices. So you just add individual, like, the corresponding elements, and subtraction is the same way. Scalar multiplication, still the same way. You distribute the k to each of the components. All right. So let's just do a couple of examples. It's not worth going over that in that much detail. All right. We're going to do 2w plus y minus 4z. So this is 2 times the vector w plus 2, 0 minus 4 times -1, -4. All right? So now I distribute the 2 in here. So it's 4, -10 plus 2, 0. Okay, and now here, it's totally up to you. You want to distribute the negative. You don't want to distribute the negative. But let's distribute the negative. Let's make it more fun. So then it'll be plus 4, 16. Does everybody agree with that? Yes? Now, to add, okay, so to add, we're just going to add the corresponding components. So component A gives us 10, comma, component B, are you sure? Positive 6. That's what you meant. I say -26 all the time when I mean 6. Yeah, when people ask my son's age, who's 6, I say he's -26 all the time. Yeah, okay. So, yeah, I know. I'm not sure. Okay, so I'm gonna speed through this one. So this is 6, 0. Okay, now look, I'm gonna be a rebel. I'm gonna be a rebel and leave the negative outside for this one. So this is gonna be -2 and -8, just for fun, because you could do it both ways. So now it's 6 minus -2, which is 8, and 0 minus -8, which is 8, and there you have it.
So wait, so that means the distance from
Now, sometimes what we need is not the full-on vector with its, with its might and glory, right? Sometimes what I need is the vector just for the purposes of direction. And if I'm just going to specify a direction, do I really need to draw a huge vector? Not really. I could do a small one, 1 unit long, and that would just specify a direction. Well, a vector that is 1 unit long is called a unit vector. Okay? Whoops. So, a unit vector is a vector with a magnitude of 1. Now, suppose you have a vector v. That's this blue one, and it starts here and ends there. It's the black one is superimposed on it. So that is a vector v. Its unit vector u is usually the one for unit vector, the symbol for unit vector. Its unit vector u will have the exact same direction of v. It's just much shorter. It's got a magnitude of 1. Okay, so so you can see the diagram here of u and v. Now, if you've got a unit vector, if you've got a vector v and it's 5.3 centimeters long, what do you have to do to it to make it 1 centimeter long? Divide by what? 5.3. So to find the unit vector u given a vector v, we just divide v by its magnitude. Okay? And this is a thing. It might sound like I'm insulting your intelligence, but we're going to come back and forth. So I should have made those bold, or I should have put the symbols on top. So they do need symbols. Okay? So the u vector is just the v vector divided by its magnitude. So here, let's find the unit vector u. Okay? So this is my v vector. I need to find the unit vector. I need to find the unit vector specific to v. So what I need to do is first find the magnitude of v. All right, so what is magnitude of v? It's the square root of 4 squared plus -2 squared. And yes, you could totally leave out the negative because you're squaring. So at the end of the day, this is root 20, which is 2 root 5. So that's magnitude of v. Okay? Now, I need to find the unit vector u. What I'm going to do is take my vector v and divide it by the magnitude of v. Now, okay, this is what we're doing. Is there another way to write this? Can I also write this as 1 over v magnitude times vector v? Can I also just split it up, right? Okay, so let's, So let's find u then. U is 1 over 2 root 5 times my little vector v. Okay? So what am I going to do? I'm going to distribute. So this is, let me go here, u will be 4 over 2 root 5, comma, negative 2 over 2 root 5. So this is 2 root 5 over 5. You rationalize, right? 2 root 5 over 5. Comma, negative root 5 over 5. That's the unit vector u. Huh? Yeah, you rationalize. Okay, so that's the unit vector u. If you were to find the magnitude of that, so a squared plus b squared in a square root, you would get 1. Okay, but now that gives you a unit vector. That's a tiny little unit vector. It says go to the right, 2 root 5 over 5, go down, negative root 5 over 5, and it gives you the same direction as that vector. Okay? Huh? What's the point of what?
Why do you have to make it smaller?
To find the unit vector? You'll see as we do some of the other stuff, but it turns out it's a lot more useful than like the full-on vector sometimes. Okay? All right. So, unit vectors. Okay, so unit vectors can be along the direction of a vector, or they could also be just along the x-axis or the y-axis. Okay, so if a unit vector is along the x-axis, okay, if it's a unit vector, a horizontal one along the x-axis, it's got a special name. It's called I hat. I hat. Right here. And so this is the horizontal one, and this is the vertical one, j hat. Yeah. So to make this blue vector AB, right? How can I make it? I could have 3 little I hat vectors and 4 little j hat vectors, and I can make that vector A comma B. Okay? So how do you make an I hat vector? Well, this is horizontal, so you go 1 unit to the right, and how much do you go up? 0. How do you make a j hat? You go 0 to the right and 1 up. Okay? All right. So DE is a vector. Yeah. Huh? So DE is a vector with initial point D, final point, terminal point E. So it says to write it as a linear combinations of the vectors I and J. So first put it in component form. How do you put this in component form? It's going to be 2 minus negative 3 and 6 minus negative 3. Okay? How much is that? That's 5 comma 9. That means, how do I make this vector? How many I hats do I need? 5. And how many j hats do I need? 9. So what I do is in as a linear combination of I and j, it's 5 I hat plus 9 j hat. Okay? Okay, so the I hat and the j hat. Okay, so do you understand what this is saying?
Yeah.
This is saying go 5 across and 9 up.
Yeah.
I is across, j is up. So this and this are different ways to say the exact same thing. Okay? Yeah. 2 different notations. All right? They mean the same. Okay? Now, what I want to do is this. In here, I want to get a graph. So remember that problem that we were solving earlier? Where was it? This one, right? So this one here, it was a vector v with components 4, -2, all right? I want to draw that vector v here. So components 4, -2. That means I'm going to go 4 to the right and 2 down. Is that right? So let's do that. Well, okay, so from here, I'm going to go 4 to the right. 1, 2, 3, 4. Is that 4? And 2 down. That's where my vector is. Is that right? Yes.
No, so the vector is just saying the slope is following the vector.
Yes.
So like for example 5, where it's 5, 9, then you could say it's the slope of that is 5/9, when this is
Okay. So the unit vector that I found was 2√5/5 and -√5/5. Could somebody convert those to decimals for me? Take out your calculators. Convert those to decimals for me.
2.2 divided by
Okay, so we are not. So when we converted it, it's 0.894 and -0.447. So now I'm going to draw that vector, right? Let's do it here. Do you see what I mean? Okay. I'm gonna get another color here. Yes. I'm gonna get another color. What color? Red. Let's do red. So the purple is the v vector. Now the red is gonna be my unit vector. So I'm gonna start here and I'm gonna go 0.894 to the right. That's right about there. Now, okay, I can't be too precise. And then I'm gonna go -0.447. There. There. Okay? So there it's this is what I'm talking about. It's super cool. So now look. Do you see what we did? The first one, this is V. Okay? And this tiny little one is U. So all I need U for, not U, but that vector U, all I need the vector U for is to specify the direction, right? So it specifies the direction. Now, if I were to take a ruler and measure V, it would give me some whatever value. If I were to take a ruler and measure U, what value would it give me? 1. It would be 1 unit long. Okay? Yes.
You say it's 1 unit long?
Yes.
Why